Hi, it's Mr. Simmons here, and we're going to go through the textbook answers in this video to the topic P8.2 for physics, force between objects. So, after this topic, you should know what forces can do, the unit of force, what is meant by a contact force, the forces being exerted when two objects interact. And remember that when two objects interact, although they exert equal and opposite forces on each other, the effects of these forces on each object will depend on the masses of the objects. The larger the mass, the smaller the effect. So if I apply the same force to a double-decker bus as I try to apply to a moped, the double-decker bus is not going to move as much as the moped because it has a much greater mass. Forces can change the shape of an object. So, for example, if I squeeze a toothpaste tube, it will change the shape of the toothpaste tube, or change its motion. So if I kick a ball, the ball will speed up in the direction that I'm kicking it, or if I put my foot out and stop a ball that's moving, then it's decelerating in the opposite direction to what its motion was, or its state of rest. So if my football is at a state of rest, it's stationary, it's not moving. When I kick it, it will start to move, so I have changed its motion, and therefore I've changed its state of rest. It was at rest, it's no longer at rest, it's moving. The unit of force is the Newton, capital N for Newton. You should know that already from Key Stage 3. A contact force is a force that acts on objects only when the objects touch each other. Now remember that that doesn't only apply to solid objects, liquid objects and gases also can apply contact forces. So for an example, an object moving through the air has a force of air resistance. That's a contact force due to the particles of air interacting with the object as it moves through them. When two objects interact, they always exert equal and opposite forces on each other, and that rule is called Newton's third law from Isaac Newton, which is also the person that the unit of force, the Newton, is named after. Okay, so let's get on with the questions then. The brakes of a moving car are applied. Describe the effect of the braking force on the car. So the braking force is going to act in the opposite direction to the motion of the car, and therefore the effect of the braking force on the car is it decelerates. So the braking force, hang on a minute, that's rather thick. Let me just change that pen size. There we go. The braking force decelerates. Fancy physics word for slowing down. Remember that from a previous topic when we were looking at acceleration. Okay, so that's all you need to say to get that 1 mark there. So moving on to question 1b. When a car brakes, the road exerts a force on each tyre to slow the car down. Describe the force that each tyre exerts on the road. So the key things to say about this is that the force is equal and opposite. What's it equal and opposite to? It's equal and opposite to the force that the road exerts on each tyre. Now remember, when we're talking about equal and opposite, when we talk about equal, we mean equal, really, we mean equal in magnitude. And in terms of opposite, we really mean opposite in direction. But for this question, it's only a 1 mark question, so you don't need to say the words magnitude and direction here to pick up that 1 mark. Okay, question 2a. A hammer hits a nail with a downward force of 50 newtons. what is the size and direction of the force of the nail on the hammer? So this again is based on Newton's third law, which is that whenever an object exerts a force on another object, or when two objects interact with each other, if you like, they exert equal and opposite forces on each other. And the unit of force is the Newton, which is abbreviated to capital N. So 50 newtons here means 50 capital N means 50 newtons here. So equal and opposite means that the size of the force, or magnitude is the fancy physics way of saying size, is going to be 50 newtons, and the direction of that force is going to be upwards. Okay, again it's just one mark. We don't need to say the words magnitude and direction to get that mark. And then for B, a lorry tows a broken down car. The force of the lorry on the tow rope is 200 newtons. How much force is exerted on the tow rope by the lorry? Okay, so again it's going to be equal and opposite, and it's not asking you for the direction, it's just saying how much. So we only need to say the magnitude of that force, which is 200 newtons, in order to get that mark. Just one mark for that question. On to question 3 then. A book is at rest on a table. Compare the force of the book on the table with each of the following forces. A, the force of the table on the book. So we're saying, how does the force of the table on the book compare to the force of the book on the table? So if we imagine the table here, and then there's a book on the table, okay, and the book is weighing down on the table with a force of some size, whatever it is, say 10 newtons, then the table is going to be pushing back up on that force in the equal size of whatever it is, 10 newtons, and in the opposite direction. So all we need to say here is that the force of the table on the book is equal and opposite to the force of the book on the table. And just to remember what I said about magnitude and direction. So when we're saying equal, we should really be saying equal in magnitude, and when we talk about opposite, we should really be saying opposite in direction, or in the opposite direction would perhaps be a better way of saying it. Now, because this is a 2-mark question, we probably really should include those words equal in magnitude and in the opposite direction to get those 2 marks. Then the force of the table on the floor. Now this time, obviously, the force of the table on the floor compared to, remember what we're doing, if we go back to the question, it says compare the force of the book on the table with each of the following forces. So the force of the book on the table compared to the force of the table on the floor. Now it stands to reason that a book weighs a lot less than the table that it is on. Therefore the force of the table on the floor is going to be greater than the force of the book on the table. And we should say greater in magnitude. Than the force of the book on the table. Now remember, it's a 2-mark question, and so to pick up the 2 marks, really we need to be talking about the magnitude for one thing, and the other thing is the direction. Okay, and it's in the same direction, because the book is weighing down on the table and the table is weighing down on the floor. So we've compared both its size, its magnitude, and its direction. Okay, so moving on to question number 4, part A. When a student is standing at rest on bathroom scales, the scales read 500 newtons. What is the size and direction of the force of the student on the scales? So the force of the student on the scales is going to be 500 newtons. Now if you had scales that were weighing in kilograms, you would need to convert kilograms to newtons, but in this case we don't, because we've been told the size of the force of what the scales are reading in is in newtons. And then the size and direction of the force of the student on the scale, so it's 500 newtons downwards. 1 mark, so you need both the size and the direction to get that mark. And then part B, what is the size and direction of the force of the scales on the student? So this is coming back to Newton's third law, which is that when two objects interact, they exert equal and opposite forces on each other. So if the student exerts a force of 500 newton downwards, then the force of the scales on the student is going to be 500 newtons upwards. Again, you're going to need to say both the size and the direction to get that mark. Then for part C, what is the size and the direction of the force of the floor on the scales? Well, we're given the figure 500 newtons, so we know that there's at least 500 newtons here involved, but also there's as well as the weight of the student pushing down through the scales onto the floor, there's the weight of the scales themselves, so it's going to be 500 newtons plus the weight of the scales, which we're not told. And the direction of that force of the floor on the scales is upwards. So we know that the student and the scales are pushing down on the floor with their weight, and therefore there's a reaction force by Newton's third law of the floor on the scales, which is equal to that 500 newtons the student plus the weight of the scales, which we don't know, and the direction of that is upwards. Okay, hope that's made everything clear to you for these questions from the textbook for P8.2. Any questions, of course, just email me. If you're stuck on anything, just email me. Stay safe and hope to see you soon. Bye bye.